Till now in function, I already discussed one-to-one function, on-to function, one-to-one correspondence, inverse function, composition of function. Today I will discuss graph of function. Definition 10, it's about the graphs of function. Let f be a function from the set A to the set B. The graph of the function f is the set of ordered pair A, B, whereas f of A equals to B. Let's see one example that you can understand. Example 20, display the graph of the function f of x equals to x square from the set of integers to the set of integers. So f of x equals to x square. Now ordered pair will be x and x square. So for 1 it will be 1 1, for 2 it will be 2 4, for 3 it will be 3 9, for 4 it will be 4 16, for minus 2 it will be minus 2 4, for minus 3 it will be minus 3 9, like this. So now let's create a graph. Graph will be like this. Here is positive side, here is negative side. Now 1 1, 2 4, 3 9, minus 1 1, minus 2 4, minus 3 9. So all are the ordered pair of x and x square. Next definition 11, it's about floor and ceiling function. Floor we can say the lower limit and ceiling is the upper limit. So the floor function is the largest integer that is less than or equals to x, and ceiling function we can say the smallest integer that is greater than or equals to x. And floor function we can represent like this, and ceiling function will be this. So in case of ceiling, this bar will be offside, and in case of floor, this bar will be lower side. Let's see one example that you will understand. For 1 by 2, its floor function will be 0. 1 by 2, ceiling function will be 1. The smallest number which is greater than 1 by 2. And for minus 1 by 2, its floor function is minus 1. For minus 1 by 2, its ceiling function is 0. 0 is greater than minus 1 by 2 and minus 1 is less than minus 1 by 2. Then for 3.1, its floor function is 3 and its ceiling function is 4. So 3.1 is greater than 3 and less than 4. So you can say its floor value is 3 and ceiling value is 4. For 7, its floor value is 7 and ceiling value is also 7. Now some properties of floor and ceiling function. First, x floor function equals to n if and only if n is less than equals to x and less than n plus n. If x value is in between n and n plus 1, then its floor value will be n. Next property, x ceiling value will be n if and only if n minus 1 less than x less than equals to n. If x is between n minus 1 and n, its ceiling value will be n. Next, x minus 1 less than x floor value less than equals to x less than equals to x ceiling value less than x plus 1. Next is minus x floor value equals to minus x ceiling value and minus x ceiling value equals to minus x floor value. Let's take an example. Suppose x is minus 5.2. Now minus 5.2, its floor value will be minus, then 5.2 ceiling value. So 5.2 ceiling value will be 6. So it's minus 6. Now minus 5.2 ceiling value, it will be minus, then 5.2 floor value. So 5.2 floor value will be 5. So in the negative sequence, first come minus 6, then minus 5.2, then minus 5. So minus 6 is less than minus 5.2, which is less than minus 5. So minus 5.2, its floor value is minus 6, whereas its ceiling value is minus 5. Next property, x plus n floor value equals to x floor value plus n, and x plus n ceiling value equals to x ceiling value plus n. Let's take an example. Suppose 1.3 plus 4 its floor value. 1.3 floor value plus 4. It's 1 plus 4, it will be 5. Now 1.3 plus 4 ceiling value, it will be 1.3 ceiling value. It's 2 plus 4. We can say 6. Next function is factorial function. Factorial function we can represent like this, n factorial. This notation is for n factorial. 1 factorial is 1, 2 factorial is 2 multiplication 1, 3 factorial will be 3 multiplication 2 multiplication 1. Here 0 factorial equals to 1. So f of n equals to 1 multiplication 2 multiplication up to n minus 1 multiplication n. So it's a continuous multiplication starting from 1 till n. Now one example of factorial. So here 6 factorial equals to 1 multiplication 2 multiplication 3 multiplication 4 multiplication 5 multiplication 6 is 720. Next is partial function. You just go through this definition. Partial function means for all domain images are not available. So we cannot find function for all. That's called as partial function. We say that f is undefined for element of A that are not in the domain of definition of f. So some elements which are not in the domain of definition of f, these are undefined. Suppose we have a set 1 to 10, but for even number only we have the function. For even number only function is defined. For rest function is not defined. Okay, so I can say this is a partial function from set A to set B. Let set A contain 1 to 10, but we have a function only for even number. So a program may not produce a correct value because evaluating the function may lead to an infinite loop or an overflow. Let's see one example. Example 22. The function f z implies r, where f of n equals to root of n is the partial function from z to r, where the domain of definition is the set of positive integers. So f of n equals to root n. F of 2 will be root 2. F of 3 will be root 3. With this I am finishing function. In function I discussed definition of function, one-to-one function, onto function, bijection or one-to-one correspondence function, inverse function, composition of function, graph of functions, then floor and ceiling functions, factorial function and partial function. In next lecture I will start sequence and summation. It's not in GET syllabus, but it will help you to understand algorithm, TOC and math also. So that's why I will cover it, but I will not go deeply. I'll just give overview of this topic. And if today lecture is helpful for you, please like, share and subscribe. Thank you.